Here we'll start. Write the heading as 2020 AL. This question was given in 2020 and this is paper. The structure is a question number 3. Third structure is a question. Third structured essay question. It's a small question, therefore we can easily write the things, right? I'll read the question, you write it. In order to determine the speed within brackets v, in order to determine the speed within brackets v of transverse waves, in order to determine the speed within brackets v of transverse waves in a stretched wire, using resonance. In order to determine the speed v of transverse waves in a stretched wire using resonance, you are provided a sonometer setup. You are provided a sonometer setup as shown in figure 1. Sonometer setup as shown in figure 1. Right. One more line to the same paragraph. You are also provided with a set of tuning forks. So, what is the aim of the practical here? It is needed to determine the velocity of transverse waves along a stretched string. To find it, a sonometer setup is provided. They have given us the figure. This is the sounding box, right? A sonometer wire goes over 2 bridges and then goes over a smooth pulley, right? So this is the first bridge, this is the second bridge, the smooth pulley, and to the end of the string a mass is connected, capital M kilogram. Please draw this figure here. This is what they have said, figure 1. Quickly draw it. Once more time to draw the figure. Anybody wants any more time to do it? Okay, I'll give you one more minute. The sonometer. This is the sonometer wire, right? I will not erase the figure, I promise I will not erase it. Right, question simple A. Questions are given as simple A, simple B, simple C, D and so on. Simple A question. In this experiment, fundamental mode of resonance of the wire is used. In this experiment, the fundamental mode of resonance of the wire is used. What is the reason for it? What is the reason for it? What is the reason for it? Why is that? In all of, listen to me, in all of the sonometer practicals, the wire is always vibrated with the fundamental mode. Why is that? The fundamental mode has the largest amplitude. Then it generates the loudest sound and it throws the paper either to a more distance. So please write, the fundamental mode has the largest amplitude. The fundamental mode has the largest amplitude. Therefore, the fundamental mode has the largest amplitude. Therefore, it is easy to detect. It is easy to identify. Therefore, it is easy to identify the fundamental mode. Fundamental mode has the largest amplitude. Therefore, it is easy to identify the fundamental mode. It is easy to identify the fundamental mode. Got it? Read the question and read the answer once again. Simple B question. Draw the wave pattern. Formed between the bridges P and Q. Draw the wave pattern formed between the bridges P and Q on the following figure 2. Draw the wave pattern formed between the bridges P and Q on the following figure 2 for the fundamental mode of the vibration. For the fundamental mode of vibration of the wire. for the fundamental mode of vibration of the wire. Full stop. Indicate on the same diagram, same equation, indicate on the same diagram, indicate on the same diagram, indicate on the same diagram by drawing an arrow, comma, the best position indicate on the same diagram by drawing an arrow the best position where the paper rider, the best position where the paper rider has to be placed, where the paper rider has to be placed, and mark it as X, and mark it as X. They have given us the bridges. The bridges are named as P and Q, right? So they have given us a figure. Look at board. This is the bridge P, and this is the bridge Q. Right? We should draw the fundamental mode of vibration. It's not such a big thing. It is something like this, and it is asked us to indicate the place where we should place the paper rider. Paper rider is placed exactly on the middle point of the wire, right? So we should draw an arrow to the middle point of the wire. We should draw an arrow to the middle point of the wire. That's what it is asked. So this is the answer for simple B question. We have already answered simple A. Draw the figure here. Next question, simple C. I think time is enough for you to draw, and I will not erase the figure. Simple C. C question has several parts in Roman number 1, Roman number 2, 3, and so on. So please write C, Roman number 1. Write the question. The distance between the bridges. The distance between the bridges in part B means this. The distance between the bridges in part B is simple L, and the distance between the bridges in the part simple B above simple B above is simple L, and the frequency of the tuning fork is simple F. Write the questions. The distance between the bridges in part B above is simple L, and the frequency of the tuning fork is simple F. Full stop. Write down an expression for the speed. Write down an expression for the speed within brackets V. Write down an expression for the speed V of the transverse waves in the sonometer wire. Write down an expression for the speed V of transverse waves in the sonometer wire in terms of simple L and simple F. In terms of simple L and simple F. Read the question. Okay. What is the vibrating frequency of the wire? It is given, look at what it is given in the question, that this length is simple length. This length is given as simple L meter in the question. What is the vibrating frequency of stretched wire at the fundamental mode? That is which is given by what is it here? V over 2L. Am I right here? This is the vibrating frequency of the sonometer wire when it vibrates with the fundamental mode. Fundamental mode means creating only a single loop. The vibrating frequency of the sonometer wire should be equal to the vibrating frequency of the tuning fork, because the wire is vibrated by the tuning fork. The wire is vibrated by the tuning fork. Therefore, vibrating frequency of the wire should be equal to the vibrating frequency of the tuning fork. But we should subject V, because they asked us to write down an expression for V. So just take 2L to the other side, then you get the answer as V equals 2LF. So in the exam, no need to prove like this. If you write the expression at once, full marks will be given. Ready? So you must identify that they are asking the same thing again and again. So you should recognize it. Okay. C Roman number 2. Write the question. C Roman number 2. Rearrange the expression in part C above. Rearrange the expression in C Roman number 1. Look at both and right. Rearrange the expression in C Roman number 1. C Roman number 1 above to determine the wave speed V. To determine the wave speed V, by drawing a straight line graph, rearrange the expression in C, in part C Roman number 1 above to determine the wave speed V. Wave speed means the velocity of the wave. Wave speed V by drawing a straight line graph. By drawing a straight line graph using the set of tuning forks. Using the set of tuning forks with known frequencies. With known frequencies, comma. With known frequencies, comma, so that the dimensions of the dimensions of the gradient, look at what, to be LT to power minus 1. LT to power minus 1. So that the dimensions of the gradient to be LT minus 1. LT minus 1 means here? LT minus 1 is the dimensions of velocity. The question asks us to draw a graph, right? To draw the graph, we should rearrange this expression. The graph should be a straight line. Gradient of the graph should be LT to power minus 1. LT to power minus 1 is the dimensions of the velocity. Therefore, gradient of the graph should be equal to the dimensions of velocity. Can you understand it? Read the question once again. So what is the equation? The equation is V equals 2LF. Velocity should be the gradient. When we change the frequency, how do we change the frequency? The examiner has given us many tuning forks. When we change the tuning forks, the frequencies are changed. When the frequency is changed, the resonance length means length of one loop. Length of one loop will be changed when frequency is changed. Therefore, L depends on F. L depends on F. Therefore, L is said to be the dependent variable. Dependent variable. F does not depend on anything. We can change the frequency at once as we decide, right? According to our wish, we can change F. Therefore, F is not dependent on anything. Therefore, F frequency is said to be the independent variable. Independent variable is always kept in y-axis. Dependent variable should always be kept in x-axis. So, therefore, let me take L to this side. Then what will happen? V over L equals 2F. Am I right here? Then I can write this equation like this. 2F equals V over L. This is one of the method. Look at both. One more thing, because it is clearly said that dimensions of the thing in the, let me take 2 also. V over 2L equals F. It is clearly said that now the graph will be a straight line graph can be obtained. What should be the dimensions of the gradient here? LT to power minus 1. Then F equals, I can write this in this format, V over 2, this L can be written as 1 over L. Okay or not? Now the equation is in the form of y equals mx. Now what is the gradient here? Gradient is V over 2. 2 does not have dimensions. Only V has dimensions. Why? V is a physical quantity. Only physical quantities have dimensions. 2 is a number. Numbers do not have dimensions. Therefore, dimensions of V over 2 is equal to the dimensions of V. Okay, dear? Dimensions of V is LT minus 1. Therefore, the dimensions of the gradient of the graph is LT minus 1. Okay, dear? So, this is the expression that they have asked. So, we have obtained the expression by satisfying all the conditions mentioned in the question. We have satisfied all the conditions given in the question. Write them all. This is the complete task. If you have any doubt, you can ask. Online students, please use the Zoom chat to ask questions. Lamai. Wait. There's a small mistake. I told you the correct method, but when I am writing, I have made a mistake. Which is the independent variable? L is the independent variable. L should be here. L is the independent variable. F is the dependent variable. Sorry. L is the what is the thing we did now? Okay, right? Sorry. This step okay. This step okay. Wait. This step is okay. This step okay, right? I think I have written it correctly. In this step, what is it? This should be L. This should be F. So this is L. This is F. I'm so sorry. 1 over F should be in x-axis. I have told you the correct one. It was correct up to this one. Once I have written this step, there was a mistake. L in y-axis. 1 over F in x-axis. Please correct mistake here. I told you the correct procedure, but when I was writing, I have made mistakes. Please correct it. Okay, when we change frequency, L is changed. So L is the dependent variable. It is kept in y-axis. F is the thing that we directly change. F is said to be the independent variable. F is kept in x-axis. Here in this case, reciprocal of the independent variable is kept in x-axis. Reciprocal means 1 over F is kept in x-axis. Right. Let's go to the next question. C Roman number 3. Please write C Roman number 3. State the independent and the dependent variables. State the independent and dependent variables of the graph mentioned in C Roman number 2 above. State the independent and dependent variables of the graph mentioned in C Roman number 2. Right. So this is the equation that we have mentioned in C Roman number 1. What is the independent variable here? 1 over f. So independent variable is 1 over f. We can't say f because 1 over f is kept in x-axis. Then what is the dependent variable here? Dependent variable. The dependent variable is simple. So this is the answer for Roman number 3. Write it. Independent variable 1 over f. Dependent variable simple L. Write them properly dear. Independent variable is 1 over f. F is used for the frequency. Dependent variable is L. L is the length of a loop or resonance length. Length of a loop or resonance length. Okay dear? But in the examination you should write only resonance length. If you write length of a loop, no marks will be given. Right. Next question. Roman number 4. Coordinates of the 2 points selected to determine the gradient. Coordinates of the 2 points. Coordinates of the 2 points selected to determine the gradient of the above graph are coordinates of the 2 points selected to determine the gradient of the above graph are, look at board and write 0.002, 22 and 0.002, 22 and 0.004, 42. Full stop. Here, simple L is measured in centimeters. Simple L is measured in centimeters and F is in hertz. Here simple L is measured in centimeter and simple F is in hertz. Simple F is in hertz. Full stop. Find the value of wave speed V in meter per second. Find the value of wave speed V in centimeter per second. Centimeter per second. Read the question once again. They have given us 2 points on the graph. We can use the given 2 points to determine the gradient. So if we know the gradient, we can find the velocity of the wave, speed of the wave. There are 2 methods to answer this question. Let me explain the first method here. Look at board. The first method, in the first method we should draw a rough sketch of the graph. X-axis 1 know F, it's okay. X-axis is okay because F is given in hertz. But Y-axis, we have a small problem with the Y-axis. Y-axis is L, it is given in centimeter. This is okay, hertz, okay. The graph should be a straight line like this. So what are the 2 points there? X value is given as 0 point in a coordinate. First gives the X value, next gives the Y value. What is the first value here? X value. X value is 0.002. Y value is 22. So you should understand that this 22 is given in centimeters. Again, next point, X value is 0.004. It is given in SI units, hertz. But Y value, again Y value is given as 42, but you should recognize that this as given in centimeters. Right? We should complete a triangle like this. Okay? And normally we mark this angle as alpha. Then we name the triangle as ABC. So this is a structured equation. There is no space on the question paper to draw such a graph. But my advice is there is another method to answer this question. But the best thing is drawing this graph separately on another paper, because for the essay questions paper they have given some rough papers. Take a rough paper and draw the graph, mark the things properly. Even the space is available on the structured paper somewhere, draw this graph. You will get a correct answer. Even a single mark can change your life. Draw it. So what is this height here? If this is 42, if this is 22, this height is 42 minus 22. 42 minus 22 means 20, but remember it is in centimeters. Do not forget. It is given in centimeters. Okay. Then what about this length here? The gap from 0.02 to 0.04. 0.04 minus 0.002. It means 0.002. This is in SI units. So no need to worry about this. Hertz mean per second. Per seconds comes up as seconds. So SI unit of this is seconds. This is centimeter. Right? Please mark them. Finally, we want to find the velocity of the transverse wing. The gradient is equal to V over 2. What is the gradient here? Gradient is equal to V over 2. So simply we can write that gradient according to the equation V over 2, gradient according to the graph tan theta. So it means gradient equals V over 2, gradient equal tan theta means gradient to gradient equal V over 2 to tan theta equals. So V over 2, tan theta mean opposite side BC divided by adjacent side AB. So V over 2 equals, BC is 22 centimeters. So what should I do? 22 should be divided by 100 to convert centimeter into meter. AB is 0.002, no problem. It's in SI unit, seconds. Meter divided by second, meter divided by second, meter per second. It is 20. It's 20. Right. So then V over 2, 20 divided by 100 is 0.2. Divided by 0.002. Just take 2 to this side. Then you get V equals 2 into 0.2 divided by 0.0. Can you do the rest of the simplifications and find V? Do it. Find V. how much is the velocity? 200 meters per second. It's not such a big simplification. I can take 1 decimal point to this side, another 1 decimal point to this side. Then what will happen? If you take 1 decimal point to both sides, then you get B equals 2 into 2 divided by 0.02. Am I right here? Because 1 decimal place changed. V equals 2 divided by this 2 and this can be cancelled out, 0.01. Now just multiply numerator and the denominator by 100. 2 into 100, 200, 0.01 into 100 is 1. 200 divided by 1 is 200. So answer is 200 meter per second. Who got this answer? That's it. Okay. Okay, now let's try for the next question. Simple D question, right? It's D. Considering the length of the prongs PRONGS, considering the length of the prongs of tuning forks, comma, which tuning fork is best? Which tuning fork is best for taking the first measurement? For taking the first measurement. Give the reason for your answer. Give the reason for your answer. Let me read the question once again. Considering the length of the prongs, considering the length of the prongs, length of the prongs of the tuning fork, comma, which tuning fork is best for taking the first measurement? Give the reason for your answer. So which tuning fork should be used first here? Tuning fork with the shortest vibrating arms. To indicate, they use another word for the vibrating arms. What's it here? Prongs. Prongs mean vibrating arms. Okay, so please write. The tuning fork with the shortest prongs. The tuning fork with the shortest prongs, comma, is used first. Tuning fork with the shortest prongs is used first. Leave a line and write reason. Leave a line and write reason. What is the reason for it here? Don't write bad answers like, okay, no need. So please write, when the prongs are shortest, because I have seen some answers, when the prongs are shortest, the vibrating frequency is maximum. When the prongs are shortest, when the prongs are shortest, the vibrating frequency is maximum. When the prongs are shortest, comma, the vibrating frequency is maximum. Full stop. Then the resonance length is minimum. We have explained this very well in the theory. In theory class, we have very well explained this. The vibrating frequency is maximum. Full stop. Then the resonance length is minimum. Then the resonance length is minimum. They always ask the same question here. You compare the past few question. This is not the first time this the same question is asked. This question has been asked many years in many past papers. You compare them, then you can identify that all the past few questions are same, similar. No big difference. No big differences. Almost the same. Right. So when the vibrating arms, when the prongs are the shortest, vibrating frequency is maximum. When the vibrating frequency is maximum, resonance length is minimum. Check that I have your minimum. Then the resonance length is minimum. Simple equation, write it. Simple equation. Vibrating directions of two prongs. Vibrating directions of two prongs of tuning fork of tuning fork at a given moment, vibrating directions of two prongs of tuning fork at a given moment is indicated by arrowheads in figure 3. Look at both. Vibrating directions of two prongs of tuning fork at a given moment is indicated by arrowheads in figure 3. By arrowheads in figure 3. They have given us a figure something like this, and two arrowheads are indicated to show us the vibrating directions of the prongs. Draw the figure here. Draw the figure. Below the figure, please write the question. Below the figure, please write. Indicate the vibrating direction of the particles of the stem within brackets S. Indicate the vibrating direction of the particles of stem within brackets S of the tuning fork at the same moment. At the same moment by drawing an arrowhead. Indicate the vibrating direction of the particles of the stem within brackets S of the tuning fork at the same moment by drawing an arrowhead appropriately on the same figure. So if you have drawn the, if you have ever touched a vibrating tuning fork, there are two methods to get the answer. First method is if you have ever touched a vibrating tuning fork, you feel the vibrations. But you never feel that your hand is vibrating like this. Your hand will never vibrate like this. It is never going to vibrate. Your hand is never going to vibrate like this if you hold a vibrating tuning fork. Your hand is not going to vibrate along the horizontal direction, means the vibrations on the stem is not horizontal. It means vibrations traveling along the stem should be vertical. The second method is the vibrations are transferred to the sounding box through the stem, through the box. Do you remember? Therefore, vibrations again should be traveling into the same direction of the stem. The third method is the vibrations of the tuning fork generate a sound wave, longitudinal wave. So the wave travels downward direction, therefore particles should be vibrated up and down. So you should indicate the arrowhead vertically downward or vertically upward. When the arms are vibrated, those vibrations are transferred through the stem into the direction of the stem. Right? If the stem is vertical, the vibrations along the stem is vertically up and down. So you can mark the arrowhead downward or upward. Vibrations may be upward or may be downward. Simple F question. No need to draw a new figure. On the same figure you can mark this arrowhead. Simple F. Masses 1 kilogram. Masses 1 kilogram, 2 kilogram and 3 kilogram can be used to stretch the sonometer wire. Masses 1 kilogram, 2 kilogram and 3 kilogram can be used to stretch the sonometer wire. Can be used to stretch the sonometer wire. Full stop. What is the most suitable mass to be used in the experiment? What is the most suitable mass to be used in the experiment? To be used in the experiment. Give the reason for your answer. Give the reason for your answer. Masses 1 kilogram, 2 kilogram and 3 kilogram can be used to stretch the sonometer wire. To stretch means to provide forces to the sonometer wire. What is the most suitable mass to be used in the experiment? Give the reason for your selection. Look at what here. You should obtain the answer. You should use some logic to obtain the answer. What is the fundamental frequency equation here? What is the fundamental mode equation? F naught equals V over 2L. And the wire is vibrated by the tuning fork. Therefore, vibrating frequency of the wire is equal to the vibrating frequency of the tuning fork, simple F, and this is equal to V over 2L. We are going to select the mass that should be used first. Am I right here? So F equals, what is V here? 1 over 2L. V is square root T over N. So F equals 1 over 2L square root T is capital Mg over simple M. Okay dear? We always select the masses tuning fork, everything to have the smallest vibrating length. Right? If M is larger, F will also be larger, L will be smaller. Okay, dear? If you can't understand that maxim, if you cannot read the equation like this, how did I read? If M is larger, F will also be larger. When M and F are larger, L should be smaller. Therefore, we should select the largest mass. Okay, dear? If you cannot understand that thing, you must write the equation in this format. Look at both it. F equals a constant. That constant is 1 over 2 simple G simple L, indicated by that constant, into a constant over L into square root capital L. So what is K here? This K indicates half simple M simple G. Okay, dear? Then you should take two values. For example, let me take F is 1000 Hertz and K is 1, for example. K is 1. K is 1, F is 1000. And let me take, we want to find L value and M value. We want to compare L and M. Am I right here? Let's say M is 1 kilogram. Then what will be F? Sorry, what will be L? If so, we can interchange the terms. Let me write one more step. So L equals K over F square root capital L. Am I right here? So then L equals K over F square root capital L. Let me clean the board. I don't have enough space to write. Then L equals K is 1, F is 1000, M is 1. What is square root of 1 dear? 1. So L is 1 over 1000 meter. Am I right dear? So then what is L dear? .0.001 meter. So what is L then? In how many? It is just 1 millimeter. Am I right there? Would you please write this saying a note? Let's get an experience. Saying a note, write them all. Write all these things saying a note. After that, after we write this note, let's write the answer. Write down this note. We are going to find the resonance length L, right, by changing the mass capital L. Do it. Right. Now do the same calculation under the same conditions. What's the condition here? F is 1000 Hertz. We select the tuning fork with the highest frequency. We already know it. F is 1000 Hertz. We always select the tuning fork with the highest frequency. K is 1. I put some imaginary numbers. Now mass is, let me take 4 kilogram. If mass is 4 kilogram, what will be L? Can you find it without my help? Friday. Find the resonance length if mass is 4 kilogram. They have given 1, 2, 3, but let's use 4 because it's easy to simplify. Find the L. So what is L then? K is 1, F is 1000, square root M is 4. Square root of 4 is 2. 2 divided by 1000 is 0.002 meter. Am I right there? So then this is equal to 2 millimeter. Now you see, even we select 4 kilogram, what is the length here? 2 millimeter. And what is the instrument that we use to measure the length? Meter rule. Right? So, if we use 2 kilogram, length is very small. Can you understand it? Length is very small mean, what about the percentage error of the length measurement? Even in the exam, you can quickly do this kind of calculation by putting some arbitrary values. Just imagine some values. You should use the same frequency, same K value. After that, change M, check L. Now, what is the problem there? Both 1 millimeter and 2 millimeter very difficult to be measured by using a meter rule. Can you draw a line of length 2 millimeter if you don't believe me? It's very difficult. And it is again very difficult to measure a very small length such as 2 millimeter by using a meter rule. Therefore, it's better to have a length greater than 10 centimeter. Why is that way? When we use a meter rule to measure a length, that length should be greater than 10 centimeter. We have learned that part, that logic in units, dimensions, measuring instruments length. Least count of a meter rule is 1 millimeter. To have a percentage error equal or less than 1%, a measurement taken from a meter rule should be greater than 10 centimeter. Now they are very much smaller than 10 centimeter. Actually, it's better to use a larger mass, even 3 kilogram. That's why, okay dear, even 4 kilogram is not enough. So what is the answer here? Let me read the question one more time for you. Most of the people, many of the people may have forgotten the question because all of you are Sri Lankans. Let me read the question again. Masses 1 kilogram, 2 kilogram and 3 kilogram can be used to stretch the sonometer wire. What is the most suitable mass to be used in this experiment? Give the reason for you, for your selection. So we should use the largest available mass. Actually, it is better to have 10 kilogram. or 20 kilogram. Is it available? It's better to have a very large mass. Unfortunately, it is not available. Then we want to use the maximum mass, largest mass. At least it's better to have a 10 kilogram mass. But is it available? No. Then we have to be satisfied with the best among the available things. What do we do here? We have to be satisfied with the best among the available things. But internally we know that it is not the thing that we really wanted. Same here in physics. So we write answer. 3 kg mass is used. So what is the answer here? 3 kg mass is used. 3 kg mass is used. 3 kg mass is used. Leave a line and write reason. Reason. When the mass is larger, comma, the resonance length is also larger. When the mass is larger, the resonance length is also larger. The resonance length is also larger. 4 kilogram, 2 millimeter. 1 kilogram, 1 millimeter. Okay, dear? Resonance length is also larger. Full stop. When the resonance length is larger, comma, percentage error of the length measurement is smaller. Percentage error of the length measurement is smaller. Percentage error of the length measurement is smaller. Then the accuracy is increased. Then the accuracy is increased. Then the accuracy is increased. Right? Let me read the answer once again. 3 kg mass is used. Reason. When the mass is larger, the resonance length is also larger. When the resonance length is larger, percentage error of the length measurement is smaller. Percentage error of the length measurement is smaller. Then the accuracy is increased. Then the accuracy is increased. Listen here. Earlier I thought that resonance lengths are larger. Can you understand here? But once I do the calculation, I understood that these resonance lengths are very small. Can you understand here? If resonance lengths are very large, the sonometer wire length will not be enough to measure it. Can you understand it? For example, we get a resonance length of 40 centimeter. Sonometer, maximum length of sonometer wire is 20 centimeter. So then we can't do the practical. What's it here? Let's say we arrange the things, the masses and tensions, tuning fork, everything is arranged. According to the arrangement, the resonance length should be 40 centimeter. Okay, dear? It means length of one loop 40 centimeter. But the length of the sonometer wire 20 centimeters. So can we do the practical? We can't do the practical. In that case, we want to reduce the resonance length. To reduce the resonance length, we should select the tuning fork with the largest frequency. We have already learned it. What is the upset with this method here? When we are trying to measure the resonance lengths, they are very small. When the resonance lengths are too much small, no problem, one loop will be formed. But what is the problem there? When we are trying to measure 2 mm, 1 mm lengths by using a meter rule, the percentage errors will be very large. Okay dear? So then we have to do something to increase the resonance length at least to be equal to 10 cm. Okay dear? To increase the resonance length at least to be 10 cm, we have to increase the mass. But we, the future paper question, but we cannot connect a mass something like 20 kilogram. Then what will happen? If we connect a mass 20 kilogram, tension in the wire is equal to capital Mg. So M is 20, G is 10. This is 200 Newton. So if you use a thin wire, the wire may be broken. Can you understand here? So it means there are limitations. Resonance length should not be too much small like this. Resonance length should not be too much small like this. Therefore, to increase the resonance length, we have to increase the connected mass. One thing. The second thing, resonance length should not be too much long. If it is very long, length of the sonometer wire will not be enough to have a one loop. Okay dear? So it means it should not be too much short. It should not be too much long. It should be in middle range. Something like day-to-day life. Okay dear? Too much short means very high error in the length measurement. Too long means wire is not enough to have a one loop. Okay dear? So it should be in a middle range like 10 cm, 20 cm, 30 cm and so on. Okay dear? Please write special note. Special note. Special note. When a sonometer practical is carried out, 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 comma, the resonance length should not be too short. The resonance length, within bracket simple L, should not be too short. TW should not be too short. TOO, too short. Full stop. Then it will be very difficult to measure the resonance length, and then it will be very difficult to measure the resonance length, and then it will be very difficult to measure the resonance length and percentage error of the length measurement will be larger. Percentage error of the length measurement will be larger. Percentage error of the length measurement will be larger. Next line, next point. Then the percentage error of the length measurement will be larger. Next line, next point. Similarly, the resonance length should not be too large. TOO, too large. Similarly, the resonance length should not be too large. Full stop. Then then the length of the sonometer wire, will not be enough. Then the length of the sonometer wire will not be enough. To make a single loop. Will not be enough to even make a single loop. Then the length of the sonometer wire will not be enough to even make a single loop. Okay, dear? Should not be too short, should not be too long, should be in the middle ranges such as 10 cm, 20 cm and 30 cm. So this special note is given for the future paper questions. So those are the things that can be asked in future question papers. Read the special note here. Read, check whether you can understand it. Next question. Simple G question. If the wire is resonating with a frequency simple F, if the wire is resonating with the frequency simple F, comma, write down an expression for the amplitude. Write down an expression for the amplitude within brackets capital A of the wire if the wire is resonating with the frequency simple F, comma, write down an expression for the amplitude within brackets capital A of the wire in terms of simple F, and simple G, when the paper rider just jump off. Okay, dear? Right. Look at board here. At what time the paper rider thrown away from the wire? When the wire vibrates with a single loop. Am I right here? So, look at board. Let me draw the wire. Right. So, and let me mark the amplitude of the wire. What is the amplitude? Capital A. This is one of the position. At this time, what is the velocity of the wire? What's the velocity of the wire at this time? 0. Next instant, what will happen? Wire will start to move downward. When the wire start to move downward, what about the velocity of the paper, dear? Paper was pushing up by the wire. Try to understand. The paper was pushing up by the wire, right? And once the wire reaches to here, velocity of wire becomes 0. But velocity of paper rider, is it 0, dear? No. When the wire start to move downward, paper rider will continue its motion further. Can you understand that point? Actually, we should consider another position here. This is Q, this is P. P and Q are the names given to the supports, right? The bridges. When the wire is in this position, what is the velocity of the wire here? Maximum. Am I right there? So, if I indicate the paper rider by a small dot, paper rider is pushed up by the wire. Got it there? And just after the wire will start to move downward. At that time, the connection, the touch between paper rider and the wire, they will be separated. Can you understand? The question asks us to do something at the time when the paper leaves the wire. Read the question. Read the question. If the wire resonates with the frequency f, write down an expression for the amplitude A of the wire in terms of f and g when the paper rider just jump off. Paper rider just jump off at this time. Jump off means the connection between wire and the paper rider becomes zero. There is no connection. When the paper rider jumps off, it means when the paper rider leaves the wire, is there any connection between wire and the paper rider? No. Please draw this figure. Draw this figure because I want to explain the answer. Okay. Right. At this instant, if I consider this instant, right, the gravity of the earth applies a force of mg Newton and the wire gives a force simple F Newton. Mark it. Mg force is given by the earth, gravity. F Newton force is given by the wire. Right, now please write at the time when the paper rider is going to leave the wire. In next moment it will leave the wire. At the time when the paper rider is going to leave the wire. At the time when the paper rider is going to leave the wire. At the time when the paper rider is going to leave the wire, at the time when the paper rider is going to leave the wire, comma, the wire gives a force of simple F Newton to the paper rider. The wire gives a force of simple F Newton to the paper rider. To the paper rider. Okay, dear? At that instant, same line, same point. At that instant, simple F is equal to the gravitation attraction force. At that instant, simple F is equal to the gravitation attraction force. Simple F is equal to the gravitation attraction force within brackets mg. Look at board here. Wire, at this moment, wire has the maximum velocity. As wire is moving up with the maximum velocity, paper rider cannot leave the wire. Am I right here? So paper rider is moving up with the wire until the wire reaches to its maximum displacement position. At that time, wire gives a force of F, gravity gives a force of mg. The next millisecond, within next nanosecond, the paper rider will leave the wire. At that time, F is equal to mg. Am I right here? So wire will start to move downward, paper rider will be moved further up because it has a certain velocity. Okay, dear? So that's this situation. So what's the condition? The first condition is F equals mg. Please mark this thing. Write the equation number 1. In the exam, you don't want to write this much of things because I'm trying to explain the situation. But what is F here? You can assume that, continue, leave a line and write. It can be assumed that the paper rider is oscillating. It can be assumed that the paper rider is oscillating with the wire as a simple harmonic motion. It can be assumed that the paper rider is oscillating with the wire as a simple harmonic motion. Am I right here? So actually what will happen to the wire? Wire is just moving up and down. This is not exactly a simple harmonic motion, but it can be assumed to be a simple harmonic motion. If the wire is oscillating simple harmonically, paper rider was on the wire, therefore paper rider is also oscillating simple harmonically. Can you understand here? What is the acceleration equation of a simple harmonic motion here? A equals minus omega square into x. Am I right there? Leave a line and write. Therefore, the acceleration of the paper rider equation. Therefore, the acceleration of the paper rider. Equals minus omega square x. Okay, dear? Right? So x is the displacement from the mean position of the wire. What is x here? X is the displacement from the mean position. Mean position is the PQ horizontal level. From the PQ level, displacement. Now what is the displacement here? Capital A. Am I right here? Next line, next point. Now the displacement, description. Now the displacement within brackets x. Now the displacement within brackets x of the paper rider. Now the displacement x of the paper rider is equal to the amplitude of the wire. Is equal to the amplitude of the wire. Is equal to the amplitude of the wire. Within brackets x equals capital A. within brackets x equals capital A. Leave a line and write therefore the acceleration of the paper rider at the time it leaves the wire, at the time it is going to leave the wire. Equation. Therefore, the acceleration of the paper rider at the time when it is going to leave the wire. Therefore, the acceleration of the paper rider at the time when it is going to leave the wire. When it is going to leave the wire equals, what is it here? Minus omega square. What is x now? Omega square x is the acceleration. Now x is equal to E. Therefore, the acceleration is minus omega square into capital A. Okay, dear? If we know the acceleration, if we know the mass of the paper rider, can't we find the force there? We can find the force. I'll explain the story. After that, I'll give you a 10 seconds method to answer, right? Let me explain it, because some of the students, they not only want A, they want to be the island first. Therefore, I am giving some descriptions. Others can remember the 10 seconds answer. So please write. Therefore, next equation. Therefore, the force acting on the paper rider at the time, equation. Therefore, the force acting on the paper rider at the time, comma, when it is going to leave the wire. At the time when it is going to leave the wire. Therefore, the force acting on the paper rider at the time when it is going to leave the wire equals, what is the equation here? F equals MA. So simply write equals MA. Simply write equals MA. ME is M. What is acceleration here? Minus omega square E. Okay, dear? So we get the answer as minus M omega square A. Name this as the second equation. Okay, dear? So what do you think about 1 and 2 equations? 1 and 2 equations give the same force. Am I right? Force acting on the paper rider is the force given by the wire. Force given by the wire is acting on the paper rider. Therefore, 1 and 2 equations are equal. Simply write 1 equals 2. It means mg equals minus m omega square A. M and m cancelled out. G equals minus omega square. Take A to this side. G over A equals minus omega square. So in the examination, at once if you write that G equal minus omega square A, full marks given. So people who don't want to be the island first, forget the description. Just remember G equals minus omega square A at the time when the paper rider leaves the wire. That's it. Write them all. Okay, if you want to be the island first, you must understand the description. If you just want A4 physics and to be the district first, then just remember that G equal minus omega square A at the time when the paper either leaves the wire or going to leave the wire. That's it. Right, final please try. When the frequency is calculated, only the magnitude of omega is used. When the frequency is calculated, only the magnitude of omega is used. Only the magnitude of omega is used. Therefore, the minus sign is not considered. Therefore, the minus sign is not considered. Therefore, the minus sign is not considered. Okay, dear? So, simply write, therefore, omega square equals G over A. And omega equals square root G over A. We consider only the magnitude, not the sign. So we don't worry about positive negative signs. But we know that, look at both. But we know that omega equals 2 phi f. We have learned this equation so many times in circular motion, in simple harmonic motion, many times. So omega equals 2 phi f, omega equals G over A. Therefore 2 phi f equals square root G over A. Just take 2 phi to the other side. F can be subjected. Do it. Subject F. Subject simple F. It is asked us to subject capital A in the equation. Check. It is asked us to subject amplitude. Not F but the amplitude. How do we subject amplitude there? I can't understand why he is asking about amplitude. Normally, if you check the other past paper question, normally F is the thing we want to subject. But the examiner asked us to subject capital A. He wants to give us a further trouble. So what should I do? Get the square of the equation, because we cannot do anything with this root. Get the square of the equation to remove the root. I can't understand why he has asked us to subject capital A. And normally F is a thing in other past papers. If you check the other past paper question, normally F is the thing we want to subject. Right, it's okay. Square of 2 is 4, square of 5 is 5 square of F is F square. When you get the square, root cancelled out, G over A, just interchange the terms as a cross multiplication. Then A equals G over 4, 5 square, F square. This is the answer. Who got this answer? Okay, you can't get it. Write them all. This is the answer for the final question. No, not the final question. Simple. There is another question. One more question is there. So no need to remember all these descriptions, but because those things are too much. But some students, they want to know the reason. That's why I have explained. Some students are there, they are highly scientific, they want to know the reason. But if you want to know only the answer, just remember that omega square A equals simple G when the paper rider leaves the wire. So this is the only thing that you want to remember. Okay dear, please write this note also. Omega square A equals simple G when the paper rider leaves the wire. That's all you want to remember. Simple H. Write the final question. Please write down the final question. Write down a possible error. Write down a possible error that could happen. Write down a possible error that could happen when determining the resonance length. Write down a possible error that could happen when determining the resonance length simple L, an action that you would take to minimize it. Write down a possible error that could happen when determining the resonance length simple L and the action that you would take to minimize it, and the action that you would take to minimize it, Actually, we have already answered that question in a past paper question. Do you remember that there was, I don't remember the year, there were two possible errors when you take in the resonance length delta L1, delta L2. Actually, the paper rider is thrown, paper rider leaves the wire in a range of resonance length. When I was explaining that past paper, I have said paper rider may be thrown away from the wire when the resonance length is 20 centimeter. Even it is 19.5 centimeter, paper rider is thrown away. Even the length is 20.5 centimeter, again paper rider is thrown away from the wire. So it means there is an uncertainty of the resonance length when the paper rider leaves the wire. So what should we do to minimize the error here? We slightly increase and decrease the length between the bridges at the resonance, and we repeat the practical. We find the length of the wire between the bridges when the paper rider thrown to the maximum height. Okay dear? If the paper rider is thrown from the wire when the length is 20 centimeter, we take 20 centimeter as the resonance length at once? No. We keep the length between the bridges as 19 centimeter. We place the paper rider on the middle of the wire. Tuning fork is vibrated, stem of the tuning fork placed on the sounding box. Then we check the height. That the paper rider is thrown. Then we increase the length up to 19.5 centimeter. Paper rider is placed on the middle of the sonometer wire. Tuning fork vibrated, stem is placed on the sounding box. We check the height that the paper rider is thrown. Okay dear? So like that we slowly increase the distance between the bridges. We repeat the practical and we are going to find the length of the wire when the paper rider is thrown to the maximum height. Okay dear? So what is the error they ask? First the error, second they ask what are the things that you do to minimize the error. Can you understand? So please write error. The paper rider leaves the wire. The paper rider leaves the wire at the resonance in a range of length of the wire. Paper rider leaves the wire at the resonance in a range of length of the wire. In a range of length of the wire. Same line, same point. Therefore, there is an uncertainty. Therefore, same line, same point. Therefore, there is an uncertainty of the resonance length. Therefore, there is an uncertainty of the resonance length. Uncertainty of the resonance length. Then they ask us to write down the action. Please write action. The thing that we do to minimize the error. Action. Please write. The experiment is repeated. The experiment is repeated several times. The experiment is repeated several times by slightly adjusting. The experiment is repeated several times by slightly adjusting. By slightly adjusting. By slightly adjusting the resonance, by slightly adjusting the distance between the bridges. By slightly adjusting the distance between the bridges. By slightly adjusting the distance between the bridges, comma, at the resonance, by slightly adjusting the distance between the bridges at the resonance, comma, and the maximum height for the paper rider is obtained. Now I cut that sentence, no need. Practical is repeated several times at the resonance. No need to say about the maximum height and resonance because this is a structured essay question. The answer will be too much. So please cut the words at the maximum height, that is not needed. Okay dear? The practical is repeated several times at the resonance by slightly adjusting the distance between the bridges. That's enough. Okay dear? Right. So we have successfully discussed 2020 A-level physics paper, third structured essay question. That question was given from the sound wave practical, determination of the velocity of transverse waves by using a sonometer. Okay dear? And this question was given in several times, many times in the past papers. So before you go to the exam, you must answer all the past paper questions given from that practical. Then only you are okay for the future paper question given from the same practical. Right?